Hello, today we are going to talk about constant of proportionality. So in your table of contents, it is 4 and 5. And then you can go ahead and start copying down your notes. I'm going to get my calculator real fast. Alright, so today we're talking about the constant of proportionality. And if you think about what those words mean, constant would mean consistent, or if something's constantly changing, it's constantly changing the same way, okay? So two quantities are proportional. If the ratio between the quantities is equal. And if you remember yesterday, we talked about writing ratios, and you can write them as a fraction, or with the colon, and then with the number 2. Those would be all ways to write ratios. And so the ratio between quantities is equal would mean every time that you find that, it would be the same answer over and over. So once we start word problems, I think it will make sense. Mario travels 180 miles in 2.5 hours. If Mario travels the same rate, how far can he travel in 5 hours? So before we can figure out how far he can go in 5 hours, we need to know how far he goes in 1 hour. So since we want to know 1 hour, that would be our unit rate. So we would have miles and then hours. So it would be 180 divided by 2.5. And when we do that, remember you can use a calculator. 180 divided by 2.5 is going to be 72 miles per hour. So this is not what the problem's asking us, though. What the problem's asking us is how far can he travel in 5 hours. So if he can go 72 miles in 1 hour, then we can multiply that by 5, and 72 times 5 will tell us how far he can go in 5 hours. So Mario can travel 360 miles in 5 hours. So using the information about Mario's rate, complete the table below. Well, we just figured out in 5 hours he can go 360 miles. And here we can find each one of these by taking our x value and multiplying it by our unit rate. And our unit rate is also called the constant of proportionality. So this is the constant of proportionality. Each hour, it's increasing by 72 miles. So the constant of proportionality is 72. So we would take here our x value, which is 2.5, because this is our x and this is our y. And we're going to multiply it by 72. When we do that, we get 180. Then here again, take our x value, 7.5, and multiply it by 72. And that's going to equal 540. And again, all of these are miles. 10 times 72, and then 12.5 times 72. So this would be 720, and then this would be 900. So how many miles does he travel in 1 hour? Explain your answer. So Mario travels 72 miles in 1 hour. We took here 180 divided by 2.5. So when you divide, miles by hours, you get 72. And then here we can just show our work again. 180 divided by 2.5 equals 72. Okay, so mathematically here, what we are doing is we're finding the rate of change. We are finding that constant of proportionality. Essentially, we're finding the unit rate, just like we found yesterday. So the value of the ratio of two proportional quantities is what the constant of proportionality is. So it tells us what that number is. It tells us that value. The equation that we use to represent it is y equals kx. Is how you write the equation out. How you find k, how you find the constant of proportionality. So I'm going to write find k the constant of proportionality by k equals y divided by x. So throughout the unit, we'll represent the equations y equals k times x. So here, if we look back up here, our y value, our miles, equaled our constant of proportionality, which was 72, and we multiplied it by our x value, and that's how we got our y value. So it all goes, tables, equations, graphs, all of them go together, and then they all work together perfectly. So here you find the constant of proportionality by doing y divided by x, okay? Which is what we did up here. Miles divided by hours. Miles divided by hours. Y divided by x. So here in this table, we have feet is our x value. Inches are the y value. Now you know what this is because you know how many feet are in inches, but we're going to show you how it works, okay? So it says, examine the table below, describe the patterns that are true. So how do you know if the number of feet is proportional to the number of inches? So we know it's proportional. We know it is a constant rate of change by finding k, or finding the constant of proportionality. And we do that by doing y divided by x. So these numbers are math facts, so you really don't need a calculator. But 12 divided by 1, we're going to show that work. So 12 divided by 1 equals 12. 24 y divided by x. So 24 divided by 2 equals 12. Y divided by x. 36 divided by 3 equals 12. 48 divided by 4. Y divided by x. And then y divided by x. And 60 divided by 5 is still 12. So we know it's proportional. We know it changes the same rate every time because of this. Because we have the same value for y divided by x. So it says using x, the number of feet, how do you find y, the number of inches? So you take this, so you multiply the number of feet by 12. So you're taking the constant of proportionality, which is 12, and you're multiplying it by your x value. And when you do that, you get your inches, and therefore you get your y value. All right. If you go to your next page, so this would technically be page 5, we can look here and see some more practice problems. So in our equation, y represents the y value K equals the constant of proportionality, and X is obviously the X value. All right, so then here we have this table, and it tells us the miles compared to the calories burned. And it says, while training for a marathon, Keith's watch reported how many calories he burned at each mile marker. The data is shown below. So it's asking us, is it proportional to the number of miles, and explain your thinking. So in order for us to know if it is proportional, we need to find the constant of proportionality. We need to figure out what it is by doing y divided by x. So if we do that, this is x, this is y. So we're going to take 117 and divide it by 1, and that's going to obviously be 17. Here we have 234 divided by 2, 117. 351 divided by 3, 117. 468 divided by 4, 117. And 585 divided by 5, 117. When we divided y divided by x, because it was the same number every time, it does have a constant of proportionality, and it is proportional. So yes, because the constant of proportionality, which you don't have to write this out every time, you represent it with k. So the constant proportionality, which is represented with the k, equals 117. The next day, Keith ran 7.5 miles. How many calories did he burn? So in order to figure out how many calories he burned, you're going to take our equation, y equals k times x. That will help us figure out y. So k, we already found, is 117. Our constant of proportionality is 117. And then the x value here would be 7.5 miles. When you do that, you get 877 and a half, not miles, calories. All right, so what is the constant of proportionality? And you can tell me. It is 117. And it says write an equation to explain the relationship. We really already did that up here. Y equals kx. So y equals 117 multiplied by 7.5. Or you could say y equals 117 times x. And that would be more generic, just showing you that no matter what your x value is, you're going to multiply by 117 and get your y value. So to finish off your notes, you'll just do y divided by x, and that will get you your k. So this is your x, this is your y. So here we would do 6 divided by 1.5. I want you to go ahead and show me your work. And that would be 4. Here, 16 divided by 4 is 4. Here we have 22 divided by 5.5. So just to be on the safe side, save you a little time, it is 4. And then 30 divided by 7.5 will also get you 4. So here the constant of proportionality is 4. Now what I want you to do is finish these last two, and then you will be done for the day. I hope you have a good day, and I hope you have a good weekend, and I'll see you soon.